we're going to try 3 examples using sum and difference identities, okay, today. And if we get a chance, we'll do a proof as well, but I think we'll probably just stick with the 3 examples. So the first example is find sine 105 degrees in exact values. And that's interesting to us because up until now, you could only find exact values for what angles? What were the angles you could find exact values for? 45, 30, 60, 90, 180, 360, 0, those basically, and anything that had those for reference angles, right? Well, this isn't any of those. And what's the reference angle for 105 degrees? 75. So the reference angle isn't one of our special angles either, okay? However, sine 105 can be written as sine 60 plus 45. So since I can write 105 degrees as the sum of 2 special angles, and since I know my special angle identities, I can say that that is sine 60 times times cos 45 plus cos 60 times sine 45. Okay? And that is the identity on your sheet that's sine alpha plus beta. That's what we're looking at there. Okay? So any angle that I can make as either a sum or a difference of special angles, I can now find the exact value for. Okay? So I've just added to your workload there. What is the sine of 60? We did it just a moment ago. Anyone remember? Root 3 over 2. What is the cosine of 45? 1 over root 2. And the cosine of 60 is 1/2. And the sine of 45 is 1 over root 2. You do have to memorize those, or at least memorize the triangles that will allow you to remember those. So now we're going to simplify that. So we'll multiply these 2 together. And we'll multiply these 2 together. And since these are fractions with the same denominator, we're going to add the numerators. So we have root 3 plus 1 over 2 root 2. Okay? And that's the exact answer of sine 105 degrees. Okay? It's not beautiful, but it is exact. Questions about that? The second example is from your textbook. It's on page 637. It's the check your understanding number 1 in the margin on the left. Sorry, it's on the right-hand side. Okay? So I'm going to use 2 different colors because we've got an angle in quadrant 3, which we're calling angle alpha. And then we have an angle in quadrant 2, which we're calling angle beta. And it's telling you some information about some trig ratios. So it's telling you that cos alpha is -3 over 5. So that means that the adjacent side is -3 and the hypotenuse is 5. And it's telling you that sine beta is 1 over 3, which means that the opposite side is 1 and the hypotenuse is 3. So we have those 2 triangles, okay? We have the black triangle down here and the blue triangle up here. And the question is telling you that you are supposed to find sine alpha plus beta. Okay? So when you see a question like that, you should be thinking, oh, I'm going to use that identity from my orange sheet that is the sum of for sine. So sine alpha plus beta is sine alpha cos beta plus cos alpha sine beta. Now the problem is that I don't know what sine alpha is. I only know what cos alpha is, and I know what sine beta is, but I don't know what cos beta is. What am I going to do to find those? What is it that I'm missing to allow me to find those values? Philip, what do you think? Well, so this is angle alpha on the black triangle. How am I going to find sine alpha? What is it that I need to know to find sine alpha? I need the opposite side. So to find the opposite side, I'm going to use Pythagoras. So go ahead and use Pythagoras and tell me what the opposite side is going to be. So I'm hearing it out there. It's 4, and I'm going to remind myself that it's negative 4 by putting a negative there. Okay? Now let's do the same thing for the blue triangle. We need to find the adjacent side on the blue triangle. So that is going to be root 8. Okay? So now I can figure out what sine alpha is, because sine alpha is opposite over hypotenuse. So that's negative 4/5. Cos beta is adjacent over hypotenuse, so that's negative root 8 over 3. Cos alpha is negative 3 over 5. And sine beta is 1 over 3. Okay? So I drew the diagram. I found the missing sides of my triangles. I used the addition identity for sine to expand to this, and then I'm substituting in those ratios. Now I'm going to multiply. A negative times a negative is a positive, so I have 4 root 8 over 15 minus 3 over 15. Okay? Now this is simplifiable, and you might be tempted to simplify this, but because we have a common denominator here, what we're going to see in the back of the book is going to be this. Only it's not going to look like that, because that can be simplified yet again. What's the one thing that we could simplify about this? Any ideas? We wouldn't leave the root 8. Because root 8 gets simplified to be, 2 root 2. So we'd have 8 root 2 minus 3 over 15. And that would be the final answer in simplified form. We do want it simplified, but you'll see it in this form here. Okay? Okay, so the question I want to do is on page 638 in your textbook. The check your understanding number 2, there's an A and a B, so we're going to do A and we're going to do B. Okay? So in A, it's asking you to simplify this expression and then evaluate if possible. So you look at it and you say, oh, sine 8x cos 3x minus cos 8x sine 3x. And you think, that looks familiar to me. That looks like something on my orange sheet. So you look at your orange sheet and then you try to determine which identity is this equal to, or which one is it similar to at least. So look on your orange sheet and tell me which one this reminds you of. It looks like this one, right? The sine alpha minus beta. Does it not? So what that means for me is it's going to be sine 8x minus 3x. And 8x minus 3x is 5x. So it's sine 5x. So this simplifies to be this. Okay? Are we okay? Okay, questions about that one? So again, these kinds of problems are mainly recognizing and then applying the correct identity. So look at this bottom one. You look at it and you think, oh, that's pretty ugly. Now clearly that's one of the tan ones. The question is, which tan one is it? Is it the tan with where you add the two angles, or is it the tan when you subtract the two angles? Which one is it, Shia? So look on your orange sheet. Which one does this match up with? The one where you're tan alpha plus beta, or is it matching with tan alpha minus beta? Yeah, it looks like the alpha plus beta one. So since alpha is pi by 6 and beta is pi by 12, we just want to add those. Pi by 6 is 2 pi by 12. So I have tan of 3 pi by 12. And pi by 12 simplifies. What's 3 pi by 12 when I simplify it? Pi by 4. So that is simplified form. Except for, what is the tan of pi by 4? Everyone should know that one. Tan pi by 4 is? Pi by 4 is 45 degrees. So what's the tan of 45 degrees? 1. Okay? Questions about that one? Okay. I'm going to do the proof with you right now too. I know I would like to give you some time to practice, but then it's all on one lesson on the recording, okay? And then you can actually do all of the homework, and but we'll have more time to practice it tomorrow, okay? So the proof is, prove that sine pi minus x is the same as sine x. Now, you could probably see the graphs in your mind, because those two graphs, the sine pi minus x is just a translation of sine x. And if we translate sine by pi, do we get the same value? That's the question. Okay? So if this proof works out, then it does. So what we're going to do is take this side, the more complicated side, and prove that it's the same as sine x. And we're going to do that using sine pi cos minus x, or sorry, cos x minus cos pi sine x. So we're just using the difference identity for sine because here we have a difference of angles with sine. So I'm substituting into that identity. Okay? What is the sine of pi? That's what this all hinges on, is that do we know what the sine of pi is? Do we know what the cosine of pi is? What's the sine of pi? Okay, how many people know what the sine of pi is? And what is it? It's 0. So I have 0 times cos x. And now what is the cosine of pi? Cosine of pi. Think about the graph of cos x. At pi, you get -1. So now I have 0 times anything is just 0. A negative minus cos x, or sorry, subtract -1, that's plus. 0 plus sine x is sine x. And so the left side equals the right side for all real numbers, because it's an identity. We prove they're the same. Okay? Questions for me?